So my name is Macy. Today I'm going to talk about Project Tango. Before I go into about the topic, I will do a little introduction about who I am. I'm Macy, probably have saw it on the page. I am the Google developer expert for Wearable. That's why actually I got into Tango, because I'm very interested in anything that's exciting and new. And I'm happy to be a game developer and make a lot more video games. That's also why I'm very interested in Project Tango. So what is Project Tango? It sounds very sci-fi-ish, right? It's like move around. It actually has to do with move around. If you have ever seen any pictures or Googled around what Project Tango, you'll see people going crazy, like going up and down or rotating around. And so Project Tango, it's a device. Okay, let me speak louder. Project Tango is a device. It looks very humble. It's just like a regular tablet. It is a technology that combines hardware and software to understand space. It sounds very, very large. So think about if your phone and a tablet can understand its own environment. So most of the time when we interact with our phone, it only understands what's within this little space. Probably it has a camera, probably it has the internet, but anything outside of it, it just could not understand it. So it has a little camera. It takes image around the environment, and it also has a depth sensor. So both technology combined together with image processing in order to pretty much scan the environment in real time and figuring out what's the distance and depth between things, and helps the machine to have the eyes like we have, like to understand space. So the front side is just like it has ambient sensor and it has headphone jacks, just like everything else. But the magic is what's inside and what it can do. Space. We always want our machines to understand space. How many of you have ever used this, like?
This cat?
No, not a cat, but the vacuum cleaner is the automatic one, right? So it's advertised as amazing. It's like cleans everything on its own. But in real life, you always get stuck under the couch, or you have dead corners never being cleaned. So understanding environment takes ages as us to getting better at it. Like we are trying so many ways, like Connect try to understand space, understand user movement, and Oculus, like the 3D game console, try to put a camera in front of you, understand how far you are away from the camera. So there's so many ways people are trying to understand space. It's not just because it's fun, it's also because it's very useful. And space is such a big word, that's categorizing it in something that's straightforward. So as Project Tango, they categorize space learning into 3 categories. The first one is motion tracking, so it actually understands where we have been walking through and how far we have gone, and it knows our route from point A to point B. So the first one is motion tracking. And the second one is depth perceptions. I believe many of you have seen those little posts on social networks saying this picture tricks your eyes, and that picture makes you think something's bigger than the other thing. So that's how human eyes works. We have certain technology in ourselves to be able to understand height, distance between objects. Project Tango actually also using this kind of similar way to understand space as well. So the third one is area learning. It could actually scan the whole environment and remember where everything was. Like our human eyes are so magical, we don't know how powerful our eyes are. After you see this room, you pretty much remember where the stairs are, where the washrooms are, and where the projectors are. And when all the hardware and our phones have this kind of technology, can do what we do. So probably our phone will understand, okay, I remember where the charging station was, and my battery is low. Maybe I should go back to the charging station, charging myself. And that's just like a very basic example. So what can we do with it? It's a lot more possibility, and they're being used in a lot of fields, like for example in utility-wise. So there are examples of we can actually measuring things in real life, of how wide it is, how big it is, and also every environment that's being scanned, we can actually sharing it with other people. So think about if I have a construction project at an empty space, I can actually scan my whole environment, send to some other designers to figure out where everything actually could really be, and they can design the whole room and send back to me, and actually I can look at this in my real space, see what's really going to be turning out to be like. And what's more exciting, actually Project Tango is being used by NASA. They're actually using Tango to help the robots to navigate the space and at some really extreme environments. So this could be using for gaming. It's just a very minor feature. It's a very small aspect of what Tango can do. So I will right now show you a couple of examples of what Project Tango can do. So maybe you're familiar with the interface. It's definitely running Android. So this one is actually a pre-scanned part of this room with some people in my scene. You can see there are people actually standing on my way that wear red shirts. If you come to DeVTO often, you know those red shirts, who wears them. And here was another person. And things are on. So we can do live scanning right now. Let me just put this thing. So it's quickly scanning who are in front of me. We understand the depths and distance and floors. So you're being scanned lively. And it knows where the floor is. You can see a lot of other technology, they try to achieve same effects, but they're not as accurate as Tango, and they don't understand depth. So I can get really low, it knows how far I am with and distance. It has a speaker around me and a table, things, and things around me. And I can actually share this file with other people, then they can understand where I was, they can revisit the same environment. It's actually a 3D, so I can walk around and see what's through here. Yeah, I can't strangle with this cable, but if you can try it, it is 3D. So it's not just like a kind of 2D motion tracking, it actually real 3D. It knows my angle, the depth and distance. So I have to focus on you, so it's closer and further. So think about if any of your phone or devices could understand, like, it's not like non-stop the tracking. Yeah, so those just what I have tracked before. It does not change. So it only renders like once, right? But at pause, I can keep going, re-render it again.
So how come we can see your hands up but not her device?
This only renders like once, right? So I stop the tracking.
So if you look at her, she's got both her hands up but we don't see her device.
Resolution price.
We can try again. Yeah. Possibly. They don't really tell people what exactly kind of technology they're using, but I can definitely tell they use a lot of technology that has to do with coloring, the lighting, and the space and depth. So it's a combine of things.
Can you use Tango for virtual spaces in real time?
Yes. So I will show some real time right now.
How accurate can you be with the images? How accurate can Tango be with the images?
It's really hard to measure the accurate. It's pretty accurate, but it definitely has its flaws. It's like it's a dev device that can tell sometimes it's kind of like not perfect. So here is another example. So people are like saying it's not like live, right? So I will do a little bit games. It's built in Unity. It's a really classic game. I think most people have played it before. So for Tango, the most important thing is to understand where floor is. So first you actually find out the floor. It's like here, so you understand the X. And I can just build things on the floor. And I can look around it, so real time. So I can look down and build more things here. So think about if you have Minecraft, you're actually building it in your real world, in your own bedroom or something. So maybe you can build a Minecraft bedroom in your real bedroom and share with your other friends. So you actually do understand like not just accelerometer, not just space. You understand like distance and depth, and you can get closer to see. Yeah. So it is real time, and apparently this tablet is more powerful than iPhone 6, and it has like a legit gaming rendering graphic card. So it's definitely game ready. But I would say it's not just for gaming. Like most people are using this for robotic kit to help robots like navigate the space. Yeah. So you can try this after my presentation, and we can keep going.
Grab a couple of leaks, I can.
Make that robot come alive.
So as I mentioned, so that's like the smaller version of this. Right now, this one's still really big. The mobile cell phone version is coming up soon. I don't know exactly when it's going to be ready, but this is just going to become smaller and smaller, and making a self-driving or self-flying robot is not going to be that far away from regular consumer anymore. And how to develop for it? It is an Android tablet. You can make things just in Android, and also it's supporting, it has Unity, a gaming SDK. So I would say if anybody just want to make things navigate, it's probably better to go with Java. If you want to make something like Minecraft games or something, so it's better to go with a professional game engine using Unity. So limits, people are saying how accurate it is, like how reliable it is. It is not super reliable yet. I have noticed it's the speed, it's like, it doesn't like people moving too fast or too slow, so it definitely has like a perfect speed you need to move at. Also, because of the technology, I can understand it actually works like human eyes. It requires lighting. So if we are using the device at an extreme dark areas, it could not adjust the scanning very well. So it requires viewable lighting instead of these things. So yeah, cannot be really dark. It has to be somewhere like with natural lighting. And that's it. Feel free to come and try this after the talk. And any questions?
I saw that on the.
Yeah, that's the thing. Along with technology, unfortunately, because they need to be regulated, like all the other technologies. So yeah, just go to US, get one, and you'll be fine.
How did you find out about this and get involved in your project?
So I'm very lucky. I'm actually involved in a program. It's called Google Developer Experts, and we get like early access to all the devices, and we just kind of get them. And I heard about this at I/O. I went to Google I/O 1 year, and they announced this like devices, but it was a kind of very silent release. They did not really make it like a really big buzz or big thing that I don't even believe even this device didn't make it to keynote. So I was there and heard about this, and just this year I this store selling the kit. Yeah. Sorry? Yes. What's the question? No, I haven't seen it. They say they're releasing it, but I have not seen it in person. Yeah. Okay.
So you're saying it needs to go to perfect speed. Is that because it just loses track of where it is? It's more of a software issue, or do you think the hardware needs?
I'm not 100% sure. So they have a demo. It will tell you sometimes you move too fast or you move too slow, or say not enough lighting or something. But I don't know exactly why. Maybe it's a combination of both. They cannot calculate it fast enough, or just like yeah.
So I guess they'll have a second version or something.
Like the phone, I assume. Yeah. Okay.
How's the battery life?
I have not really tested out. I haven't really. Maybe today is the best time to test this. See how long it lasts.
You were mentioning it doesn't do so well in dark.
Right.
Most phones, tablets, whatever, they're gonna have like an LED flash on it.
It does have a flash,
Okay.
but I have not tried with the flash now. So.
Yeah, because I was wondering like how would that work when it's just gonna cast a really distinct shadow.
Yeah. So this thing is kind of dumb in a certain
Yeah,
way.
yeah.
It doesn't work with mirrors. So it thinks anything that's a reflection is another space. So I think it heavily relied on image rendering, like things like that.
So I noticed that it has an infrared projector. Would that be for lighting purposes, or?
I believe so. It has like a pretty big flashlight, right? Yeah.
But it just said IR projector, so I presume that it's
Probably that.
bathing things in infrared so that it can actually sense.
That's possible as well. Like, because they have a combination of sensors. It does not just rely on one thing to understand the environment.
Right.
And Google has not been telling anybody what exactly they're doing with everything. So it's kind of a mystery box what exactly is the combination of things they're taking. Yeah. Okay.
How far can you see? Like, if it's all the way back here, and like, you pictures of your big trees or something?
I believe it's a performance thing. It's trying to create a bounding box so it does not really like scan things that's too far away. But I can keep going. You will scan everything else that's around. So it, so I think I can increase the distance you could scan, but I think the way they made it, it's like only within certain range of the device. Yeah.
Is it learning like using the machine learning or something?
Sorry?
Is that the application using some machine learning? Like how does it know that? I mean, is it comparing some old data?
I believe it does its own calculations, which is not really like. So I will be repeating myself again. They don't really tell people how exactly they're taking the data and how they're getting the results. They're just telling people they have different sensors and they have their own software. So it's a combination of hardware and software. So I believe they do their own data, like machine learning things on their end, which is they're not really telling people exactly where it's